Hello everyone, my name is Timothy Lee Grant. So I just made a video and I completely failed at trying to integrate or get Docker functionality into my project. So my Mac just kept telling me it's a virus, it's a virus, it's a virus. It wouldn't let me do it. So I'm like, and now I'm trying to figure out, okay, well, my project, I have two projects going on right now. I have my JavaScript project and I have my Java project, okay? And the point of both of those projects is to give me an opportunity to play with a lot of those concepts that live within those separate realms, okay? And so now I'm kind of stuck. I'm trying to think about, okay, well, where do I go from here? I already got it such that I'm able to actually communicate with the database, which or the server, right, which is the system that I created, okay? And I connected up a database, I connected up a SQL and a NoSQL database. I did these things, right? I did for the Java project, I did um, like testing, like JUnit testing. And so now I'm trying to figure out, like, okay, well, where do I go from here? And I have a couple ideas. Obviously, I think what I need to do is go back over and do a review of all of my concepts that I learned. And obviously, the first time I did it, it might be very hazy and I don't know exactly what I did. So maybe going back a second time, trying to do a recap of everything might be extremely helpful. I just went on to Copilot and I asked it the question about, like, what else can I do? So I was asking, like, what other concepts can I learn within Java, my Java project, to be able to just play around with these concepts and increase my competency. And I mean, this is kind of a question of, like, you don't know what you don't know until you figure out, right? And so it's how can I know what to learn if I don't even know what to learn? So data persistence and querying. So integrate a real database to master. So I think what this one is telling me is increase the complexity of my database. So right now my database is fairly simple. It was just a couple table or one table, a couple columns, right? Like name, user table, and column of name, column of email, column of ID, which was uh, the key. Okay, so I know that you can do like connections within SQL and you can have foreign keys and all of that. So maybe we can increase the complexity of the SQL database. Then let's see. So authentication and security. Use Spring Security to build out uh, the authentication role-based authenticate or access control. Okay, so that means, like, who you are. You can do different things. Protect endpoints. Stateless security. Testing strategy. I know that I worked a little bit with Mockito, and that was like mocking uh, output or something like that. So concurrency and multi-threading, which is interesting. I didn't know that Java had multi-threading. Well, I mean, technically Python does. What is it? The threading library, but it's not actually threading. I don't know. But okay, so sure, we can do some multi-threading if that's helpful. I don't know if that's something that we need to do, but might. I don't know. Design patterns, RESTful API, we already did a lot of that. Microservice architecture, so this might be useful. I'm thinking maybe we play around with this one a little bit. I'm not sure. And then observability and monitoring. Use Spring Actuator. Centralize logs with logback and send elk, Prometheus, Grumna, trace HTTP requests and monitor health endpoints. Okay. Messaging and event-driven architecture. Add a messaging layer. Okay, so I think these things right here might be good. Creating a microservice architecture. I think that I can play around with that idea. Add monitoring, okay? And then do event-driven architecture. Okay, so let's start with here. I have my Spring Boot application. How would you suggest doing the microservice architecture? Let's see. In that section, you mention 3 points. Can you go into them? Give me, what does this mean? Can you explain more? Okay. So yeah, we'll first try to do this microservice architecture, and then after we kind of understand that a little bit more, maybe we do this observability and monitoring, then event-driven. But I see Kafka here, and I see Kafka up here. Okay. So maybe we can knock both of them out at the same time by using Kafka. I'm not sure. Okay. So service, okay, so service to service communication, REST or Kafka. When you break your app into smaller sections, user service, product service, they need a way to talk to each other. So, okay, so I think this is saying I break it into separate, smaller services, and now there's a question of, okay, well, how do these services talk to each other? And we can use REST, or we can use Kafka. I think that's what it's saying. So REST, it would be like my microservice calls or sends a request to an endpoint. I'm guessing that's how that works. Okay, so let's look at REST, and then let's look at Kafka and try to understand what's happening, okay? And then figure out what we need to do for ourselves. So each microservice exposes HTTP endpoints. Okay, so in the REST, if we're using the REST methodology, each of the microservices will have certain HTTP endpoints. And other services will call them. Use Spring's REST template or web client for non-blocking calls. Okay, well, first thing is I've heard this term before, but I want to make sure that I understand what it actually is. What is a non-blocking call? Can you give me an example of a blocking and non-blocking call? Is it like when I have to wait for the call to be resolved before I move? I think that might be what it's talking about, but I just want to make sure. This is easier for synchronous communication. So, example, order service might call product service to check product availability. So, web.client.create and then the endpoint, okay, .get .uri here, retrieve body.mono, okay. So we don't quite know what that means yet, but right now we're just trying to get the major overview of everything. Okay, so via Kafka or RabbitMQ, okay? So for event-driven architecture, services, hold on, event-driven. That was the third one though, right? This is microservice architecture and event-driven architecture. Okay, question number 2. In the Kafka section, you say it is event-driven architecture. But you also said it is microservice architecture. Is it both? Is it both at the same time? Okay. So let's just keep looking at this Kafka and see if we can understand it a little bit. Okay, so for event-driven architecture, okay, I'm just going to take that at face value, event-driven architecture. Services publish events rather than directly call each other. Publish events, okay, publish events. I'm just trying to put that in my head. So services, the microservices, publish events, okay? And then I'm guessing that, I actually don't know. We'll have to figure out what happens when you publish an event. Okay, so example, user service emits an event like user registered. Email service listens to that and sends a welcome email. So you can have listening services that will respond to certain events, okay? It's asynchronous, decoupled, and scalable. Great for high-performance systems. Okay, interesting. So, number 2, OpenFang, whatever, and Spring Cloud Config. Okay, so once services multiply, config and service all gets messy. These tools help streamline. So this one is a declarative REST client for calling other services, okay? You define an interface and Spring Cloud generates the implementation, okay? So I think what this means is that's gonna be number 3. Does this mean that is a replacement for the Kafka, no, slash REST methodology of microservices you mentioned in number 1. Okay, so declarative REST client for calling other services. So we have something like this, public interface. Okay, so client, get mapping. So this is the endpoint, okay? Product by ID. Okay, so Spring Cloud configuration centralizes your configurations across all services. Store all app configurations in one Git repo. Okay? Services fetch their config at startup. No need to duplicate. Is this YAML? YAML files? Okay. It simplifies versioning, secrets management, and environment specific configs. Okay. Number 3. What did I even ask? Okay. Now I remember. Number 3 is circuit breakers and service discovery. So these help your microservice stay resilient and dynamic. Circuit breakers. So just thinking about like the electrician circuit breakers, what do those do when there's too much current being taken in through a certain path? You will have a circuit breaker that will cut the connection between that path. So all of a sudden it helps you stop a potential fire from coming, because if you have a whole bunch of current, that's not good. So you need to break the path before you start a fire. So I'm wondering, maybe I'm curious if this is kind of similar, if it's like a safety mechanism right here. So these help microservices stay resilient and dynamic. So circuit breaker, example is Resilience4j, prevents cascading failures. Oh, okay, there we go. When one service goes down, automatically blocks, there we go, repeated calls to failing services. Okay. Service breakers. Oh my goodness. Okay, so service directory. Instead of hard coding IPs, URL, use a registry. I'm just going to create a notes.txt and try to just like put all of the things that I need to study. I need to topics, need to study. Okay. So now I'm going to, let's see, Kafka. Okay, we'll just open, what is this, Feign? Open Feign, Spring Cloud configuration. So all of these I'm essentially trying right now, as I mentioned in the beginning of the video, I'm a little bit lost, to be honest. I don't really know where I should be going, how I should be improving this project, how I should be identifying those topics to help me become a software engineer. And so right now in this video, it's more of kind of like a discovery phase where I'm just trying to find something. And I found a lot of stuff, but now the question is like, okay, well, this is a lot. Like, what are these things? And so I'm just going to be kind of writing them out, and then I will go and watch a ton of videos on them, try to figure out what they are, how they might be useful, how we might implement them in the project. And that's kind of what my plan is. I don't know how that's going to turn out, but that's what my plan is. Right now, I think this video is just going to be a discovery phase type of video. And then I will investigate these and then figure out, okay, now that I understand them a little bit more, how can I use them? How can I play with them? And then that will be the next steps. All right. So, service discovery. Okay. I'll just put this service discovery Eureka here. Okay. And what was up here? Circuit breakers. Like this. Okay. I mean, there's a lot of stuff going on right now. We already got that. I'm going to say Kafka. Actually, I'm going to say Kafka or RabbitMQ. So come here, go like that. Okay. And then microservice. And then via REST or Kafka. Okay, so we were here, service directory. Instead of hard coding IP URLs, use a registry. Services register themselves with Eureka. Other services can discover them dynamically. Okay. All right, so let's ask these questions here. Okay, so yeah, it waits until it gets a response. So the thread is held up and can't do anything until it gets a response. So an example of a blocking would be here. REST template equals new REST template, okay. User REST template dot get for object here. So the thread stops until it gets a response. Okay, so non-blocking is doesn't wait. It continues to execution immediately and handles the response asynchronously, often via a callback or reactive stream. Okay, so web client.create. So we're chaining these methods together, okay? Create.get.uri here, retrieve body to mono, subscribe user system.out print line. Okay, the call returns immediately and response is handled later. Okay, I mean, I think that might be something that we need to look into later. Okay, so is Kafka both event-driven and microservice architecture? Yes. And here's how they mesh together. Microservices describe how your application is broken into independent deployable services, like user product order, okay? Event-driven architecture describes how those services communicate by publishing and reacting to events. I'm going to take a sip of coffee and then come back and reread those two sentences and try to understand exactly how that works. So this one's my coffee. Okay. So, I was asking, is Kafka both event-driven architecture and microservice architecture? And the answer is yes, and so that indicates that microservice architecture and event-driven architecture can coexist together. Okay? So microservice describes how it's broken up. So that's the structure. Okay? Event-driven architecture describes how those broken up pieces communicate. Okay, that makes sense. So Kafka is a communication mechanism within a microservice architecture. Okay, that makes sense. I like that. All right, so example, order service publishes an order created event to Kafka. Inventory service consumes that event. Inventory service, where is inventory service? I don't know. Consumes that event and updates stock levels. Each service is independent, but they're cooperating via Kafka. Okay. You can absolutely design microservices using REST and or Kafka. Some systems even use both. Okay, well, that might be something we want to do, is do both, just so that we get more practice. Okay. REST for direct calls and Kafka for async. I'm just going to say like, we might want to use both because says here. And I'm trying to paste it into there because it's helpful knowledge to know, like, okay, REST should be for direct calls and Kafka is for asynchronous workflows. Well, I don't quite understand what that means, but if I'm going to use both, maybe that indicates, like, that will give me some indication of which one I should use in which scenarios. Okay, so is this Feign? I don't know. OpenFeign versus Spring Cloud Config, a replacement for REST Kafka. So not exactly. They serve different purposes. Okay, well, okay. These two are for communication. This is for convenient REST client abstraction. Okay. Okay, yeah, so I'm definitely gonna need to try to understand what that is. Probably watch some videos on it. Then Spring Cloud Configuration, and I have that in my notes as well. Centralized configuration management. Okay, so this OpenFeign wraps REST calls, making them cleaner and maintainable. Spring Cloud Configuration replaces hard-coded configs. Okay. they don't replace Kafka. Okay, so I think what I'm gonna do is I'm gonna end off this video right now, and then I'm going to do another video where I try to actually implement this like microservice, Kafka, and REST. So I'm gonna try to break up my project into separate microservices. So I might just create a new microservice, right? I don't know how I'm going to do it. That's for me to decide in my next video. But yeah, so try to figure out how to break those up and um, communicate using REST and Kafka. Okay, so that's where I'm planning on going in the next video. If you are interested, subscribe, and I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you very soon.